this video, you're going to learn what AI agents are, not just in theory, but in practice. We'll look at the ideas behind modern agents, and then we'll build your very first AI agent step by step using Google's ADK. By the end, you'll understand how agents reason, act, and adapt. And you'll have code that you can actually run yourself. So what are AI agents? At the simplest level, an agent is software that doesn't just answer, it can decide and take action. Instead of generating a single response like a traditional chatbot, it looks at your request, figures out what steps need to be taken, maybe calls an API, runs code, looks at the results, and then decides what to do next. One of the clearest explanations comes from the research paper React, synergizing reasoning and acting in language models. The idea in that paper was simple but powerful. Language models shouldn't just generate text in one go. They can actually reason step by step, take an action like calling a tool or API, observe the results, and then decide what to do next. That cycle of reasoning, acting, observing, and adjusting is the foundation of how modern AI agents work. And it lines up with how it's defined. Systems with reasoning, planning, and memory, with enough autonomy to adapt and make decisions on behalf of the user. Now, not all agents behave the same way. A useful way to think about them is in three broad patterns. First, we have sequential agents. These run step by step like an assembly line. Step 1, then step 2, then step 3. They're predictable but rigid. Second, we have reactive agents. These decide in the moment. They look at the current state and ask, what should I do next? Maybe tool A one time, tool B the next. They're flexible, but they don't plan ahead. Lastly, we have deliberate or planning agents. These pause to sketch a plan, then execute. Think about booking travel. You don't just buy a flight randomly. You pick dates, hotels, and then that's the order of steps that you follow through. So which of these is the right one for you? It depends on the problem. For simple, predictable flows, sequential is fine. For dynamic, reactive works better. And for multi-step goals with dependencies, you want planning agents. Okay, that's the high-level view. Now, let's actually build an agent so you can see these ideas in action. We'll build a blog writing agent. You give it a topic, it will generate a structured outline, turn that outline into a full blog post, and then suggest the alternative titles and hooks. This is where ADK's categories comes in. As we walk through the code, notice how the planner and writer agent are LLM agents, which are powered by a model. They're wrapped in loop agents, which are workflow agents in ADK. These handle retries automatically if validation fails. And if we ever wanted something beyond that, ADK would also let us extend a custom agent by subclassing the base agent. So let's set up the environment and then go line by line through the code. First off, you need to install UV. You can do that by running the command right here. Secondly, you need to install Google ADK because we need to obviously use ADK in this. And then let's create a file called agent.py in your IDE. We need to import these key libraries, and then we can start building out our very first agent. So the first agent that we're building out is called the blog planner. Its only job is to take a topic and turn it into a structured outline. We give it the name blog planner so it's easy to identify, and we tell it which model to use, which comes from our environment file. The description is just a human readable note. The important part of the introduction is here we actually tell it what to produce, which is a markdown outline with a title, a short introduction, 4 to 6 sections with bullet points, and a conclusion. By spelling that out, we make the output much more reliable. Finally, look at the output key. We set it to blog outline. This means whatever this agent writes will be stored in shared state under that name so that the next agent that can pick it up can do it automatically. Next, we add a second agent, the outline validation checker. This one doesn't write anything new, it just checks the outline. Its instruction is strict. If the outline in state has a title, an intro, 4 to 6 sections, and a conclusion, it must answer with the word OK. If something is missing, it must answer with the word retry and explain what's wrong. That way, we can automatically decide whether to accept the outline or try again. To connect the planner and the checker, we've wrapped them inside a loop agent called Robust Blog Planner. The loop first runs the planner, then the checker. If the checker says OK, we're done. If the checker says retry, the loop runs the planner again with the same instructions. It can do this up to 3 times. This gives us a safety net, so if the model forgets something, it has another chance to get it right. Now we create another agent called blog writer. This one takes the outline we just saved in blog_outline and turns it into a full markdown blog post. The instruction tells it how to write. It should assume the audience is software engineers, skip the basics, and focus on practical insights, explain both the how and the why, and include short code snippets where helpful. It should also follow the structure of the outline with proper headings. The finished draft is saved under blog_post in shared state, ready for the next step. Next up, we're going to add another checker, this time for the post. It's called blog post validation checker. It looks at blog_post and checks if the article has an introduction, sections that match the outline, a conclusion, and clear explanations. If it passes, the checker says OK. If not, it says retry and lists the fixes which are needed. Just like with planning, we combine the writer and its checker into a loop agent called robust blog writer. This makes the system automatically retry the writing step until the validation passes, up to 3 times. Now, we wrap each loop, the robust blog planner, and the robust blog writer as tools. This is what lets the root agent call them directly without worrying about what's happening inside. Finally, we put it all together with the root agent called Blogger. The instructions for Blogger are simple. When a user gives it a topic, first, it calls the planner tool to make an outline. Then it calls the writer tool to draft the full post. And finally, it adds 3 alternative titles and 2 tweet length hooks. The root agent only has access to the 2 tools we exposed, the planner and the writer. So its workflow is clear and controlled. You give it a topic, it plans, it writes, it checks, and then it gives you a polished blog post. You've now successfully written your first agent script. The next step is to actually run it. Head into your terminal and launch it using this command with ADK Web, so you can view everything inside a simple UI. Once that's running, open the local ADK Web link in your browser and start interacting with the agent directly. To kick things off, I'm going to ask it to generate a blog on the top 10 use cases for AI agents. Let's see how it plans, writes, and delivers the results. Your sub-agents will then work together to create a blog post. And that's it. You've built and run your first AI agent with Google's ADK. We started from the idea of what agents are, then walked through the code step by step, and finally saw it come to life in terminal. Thank you for watching. Check out the description box for all the resources and code mentioned in this video. Check out this next video to learn how to connect your AI agent to an MCP server.
Hello everyone, welcome to the series of multi-agent system with Google Agent Development Kit, ADK. Have you ever wondered what exactly is a multi-agent system? And how can multiple AI agents actually work together? Or how does Google ADK makes it easier for developers for you and me? And if you have those questions, you're in the right place. By the end of the series, you will understand what is multi-agent system, and you'll be able to build your own multi-agent systems with ADK. So in today's episode, we will cover 3 parts. Firstly, what is multi-agent system? Secondly, how ADK support multi-agent system development. And thirdly, is the foundational concept of agent hierarchy. All right, let's get started. So the first part of this episode is what is multi-agent system? At its core, a multi-agent system is when individual agents work together. And to really understand it, let's break it into 3 key ideas. The first is decentralized control. There's no single boss. Each agent just decides for itself. You can think of it like a flock of birds just swirling in the sky. There's no leader, but together they form amazing, incredible patterns. So the second point is local view. Each agent only knows what's around it, but not the whole system. Imagine yourself standing in a crowded stadium. You can only see and react to the people nearby, but not the entire crowd. And lastly is emergent behavior. This is where the magic happens. For those single local rules, amazing global patterns emerge. And in this scenario, agents work together to solve a complex problem that not single agent can solve easily. So the second part of today's episode is how ADK support multi-agent system. Google Agent Development Kit ADK was built in with multiple agent support in mind. Instead of you just hack things together, it gives you 3 main types of agent and each with specific roles. So the first type is LM agent. So those are like the brain. They use large language model like Gemini to understand users' input and reasoning about it to decide what tool to pick and what to do next. And the second type is workflow agent. Those are like your manager. They orchestrate how agents working together to get the task done. They have 3 types of workflow agent. The first type is sequential agent. They run agents one after each other in assembly line. And the second type of workflow agents are parallel agents. They run multiple tasks all at once. It's like calling several APIs in parallel. And the third type of workflow agents are loop agent. You just repeat a task until it's done. And the last type of agent for ADK is custom agent. They're like the specialists. Imagine you can write your own Python logic by inheriting from base agent when you need to have the full control. Okay, now if you want to try those agents, check out the links and QR code on the screen to try them yourself. The third part of today's episode is about agent hierarchy. They're the backbone. So when you build with ADK, agents form a hierarchy like an organizational chart. So how does it work together? They have parents and sub-agent. And a parent agent can manage multiple sub-agent. And they follow single parent rule. That is, each sub-agent only have one parent agent. You can think of it like a company. The root agent is the CEO. And the sub-agent are VPs, managers, and workers. Everyone knows their roles, and together, they get the job done. Alright, let's wrap up today's episode. We talk about what exactly is multi-agent system. They are decentralized, each agent only have local view, and they have complex behavior emerge globally. And we also talk about ADK support with 3 categories like LM agent, workflow agent, and customer agent. And lastly, we covered agent hierarchy, the org chart of your system. So this is a foundation. If you want to practice, don't forget to check the link in the description. And in next episode, we'll go deeper into workflow orchestration and how agents actually communicate with each other. And I will see you there. Bye. What we're going to learn is we're going to learn how to ingest multimodal data. We're going to build a multi-agent pipeline to understand multimodal data. We also learn how to search in this multi-agent system with a graph knowledge base. And I was joined by my awesome co-host, Deborah Ayo. Hi, Ayo.
Hey, looking forward to building this graph RAG agent. So let's get started, but let's also say hi to everyone joining in from YouTube, LinkedIn, X, Twitch. Let's kind of see where people are joining in from.
Yeah, just make sure to say hi and let us know where you're from the live chat. And I saw Christina from Boston. And yeah, hello everyone. And just let you know that we also have TA in the chat to answer questions. So if you have any question, you have anything, just keep them coming. And we also answer a few questions by the end of this live. And also we have this virtual TA that you can also throw your question to virtual TA so we'll keep you supported. All right, so I'm gonna share the screen. So remember that we crash land on this planet. right? And we want to learn how to ingest this multimodal data. So what is the multimodal data we're sending today? Basically, you're taking a picture of yourself and say, or you're taking a video of yourself, say, hey, my name is Annie, and I'm an engineer. This is what I can do. Currently, maybe I'm hungry. I need some food. Or you're taking someone else taking the video, telling that, oh, they got injured. And someone else take a video of themselves saying that, oh, I have medical skill. I can treat them. So you can notice that, by sending a picture or video, they have some relationship going on in this on this planet. That some people have the skill, some people have the resource, some people has a need. So here, introduce our challenge today that we have unstructured data. We're gonna have like photo, video, and text information. Those SOS signals sent from survival. We also have our complex relationship. Who has what skill? Who need help? And where are they? And then we need to make this time critical decision that we want to match the helper need in real time. What if they have this emergency need for the medical need, right? And then lastly, we want to cover like long-term memory. How do we remember the data that all the survival upload, and especially the upload unstructured data? So this is the application you're going to build by the end of this live that you can see on the top of it. We have this 3D graph. So it's actually a real relationship in our database, including all the survival and all the skill and all the need. And at the bottom of it, you can do the AI intelligence search for this knowledge database. You can search in the real time on who can help whom. And also you can upload any multimodal data here. So we were going to build a multi-agent pipeline behind the scene to ingest any multimodal data you upload on this screen. All right, so if you, I'm excited. Are you excited to do this?
I'm really excited, but as always, before we dive into the lab, let's do a little bit of an equipment check and make sure that we all have the credits that we're going to need for the lab. So I'll walk you through that right now. So make sure that, as you can see on my screen, there's a credit link that essentially gives you free credits for the lab. So throughout the lab, we're going to be calling Gemini, creating databases, deploying agents. We want to make sure that there's no cost to yourself. So if you want to run through the lab, just make sure that you redeem these credits. And once you click this link, it's going to take you to a screen that looks like this. You're going to see your name and your email. Make sure that you're using a corporate account, not a corporate account or not an EDU account. Those tend to have restrictions. So as you're going through the lab, you may see blockers related to those organizational accounts. So we always recommend to use a Gmail account just so if you want to have no restrictions. So click here to redeem your credits. You're going to see your name, your last name, the coupon code for your credits. Just accept and continue. And that will associate the credits with your account. And then if you want to confirm that it was redeemed, you can come down over here to credits, and you should be able to see. And if you see something like this, you can ignore it. Just come back over here to your console page, search for credits. You just want to confirm that it was redeemed. And then you should see a billing account associated with your but overall, once you redeem the credits, you're good to go. So let's move through the lab. And Annie, you want to continue?
Yeah, sure. If you see on my screen that we have this link. This is today's lab. Also, please don't worry if you find it's too fast. You can always pause the video, or you can ask questions in the chat. And also, we have this virtual TA link that you can ask your questions. So just take your time, no rush. And if you type this link, Google/GraphRack, and then you will see this lab, and this is what we are gonna work on today. And I'm gonna explain give an overview of this lab. On the left-hand side, we have those different sections. So we have different emoji in front of it. So we have the rocket sign. So it's recommended you follow me, finish the rocket sign during this live stream. And we have some like coffee sign. This is optional. It's good for you to do some reading, understand deeply about the system. And we also have some optional step that you can do to deploy to Agent Engine and Cloud Run, and also play around with what has AI Memory Bank. All right. So if you have questions, you can ask in the chat, and TA will give you the link. And I'm going to walk you through, start from step 2. And I already explained this building account. If you couldn't redeem it, you can also just click this link on the chat on the lab. And next step is we're gonna open our Google Cloud Shell. So just click this link, and you will see this page. So this is Google Cloud Shell, and you may notice that this looks like VS Code on cloud, right, Io? I'm gonna still loading this.
Yeah, it looks pretty much like VS Code on Cloud. So Cloud Shell is essentially a managed VM hosted by Google. So it's persistent. So any files that you develop in Cloud Shell, you can come back to it a week later, a month later. So as we build files throughout this lab, don't worry if you want to continue tomorrow or whatever you can. Yeah, so this could be our development environment for today.
Yeah. So you can start. So we were gonna. This is the cloud. This is where we're gonna work our lab today. You have this editor to open all the files, and this is terminal that can just type any command. Yeah. So right now we open this, and next step is let's do gcloud auth to making sure our project is authenticated. So making sure that on the top right, this project. You're signing this Gmail account you're using is the same account you just claim the credit. Sometimes if you have multiple Gmail accounts, you may have some mismatch. So making sure you do that. And next step is just clone today's repo. And this is so for the folks who joined in 2 weeks ago, maybe you're familiar with that this is a way back home repo. I'm going to open it so that you know what I'm talking about. So if you joined 2 weeks ago, you're probably familiar with it. We were at level 0 and level 1, and today we are working at level 2 for today's lab. And next step is let's create our new project. So just copy this command and go to our Google Cloud Console and paste in the terminal. So you may wonder, what is this command we are just pasting? So basically, we are creating this script that help you create a Google Cloud project for you, and it will link the building you just claimed attached to it, and then it will making sure everything working, so you do not have to worry about project or building. And it's also trying to enable the necessary API for you. Usually, it takes like a minute. Or also, so don't worry if you saw error like warning or tempting, it's expected. Yeah, just let us know your progress in the chat, and if you find it's too fast, don't worry. We can you can always ask the questions. So so what it does, so the script is basically trying to create a project, and to check the project, usually it's on the top left. So currently I'm at Google Cloud Console. If you go to Google Console, if you type console.cloud.google.com, this is Google Cloud Console, right? Or you can Google search Google Cloud Console. So you can open this page, and on the top left, there's a picker, and this is, if you select that, this is a project we just created for you. It's usually start from way back home dash, and this might look different from your case. And if you couldn't find it, you can find it at this all tab. So basically, this is a project that we just created for you. And once this link successfully run, you can also see that we're pointing to this project at the yellow font over here. I'm going to zoom in case it's not clear. All right, so you just finished creating your project. And next step is you just need to run some setup script so that you're ready to go. So currently I'm at step 3, and I need to configure my project. So what I do is I just copy this command. I'm going to run it in the terminal. So you can see that if it's in the terminal, I have this emoji here. So I do know what this command does, like gcloud config set project.
Yeah, great question. So pretty much all it does is ensure your gcloud has the right project environment set up. So as you mentioned, once you have the yellow text, it kind of confirms you have the right project. But if you have to refresh your browser and come back to your Cloud Shell, you want to make sure that you're in the right project. Just do gcloud config set project and the project ID, and you're good to go.
Yeah, thank you. And then we need to enable required API. So just copy this, and then I will go back to my terminal, and I'm gonna paste it. So let's look at all the API we are trying to enable here. We enable AI platform and cloud build. So Io, do you know why we enable those?
Yeah, great question. And this oftentimes comes up when people are running labs or doing things for the first time in Google Cloud. When you enable an API, you start getting costs charged. You don't. So everything behind Google Cloud has some sort of service or API. So by enabling it, essentially we're saying we're going to be using this in the project, but it doesn't start incurring costs unless you actually start calling the service. So we're just making it available for use. So we're going to be using Cloud Run for agent deployment, Cloud Build for CI/CD, artifact registry for maintaining the image for our agent that we're building later on, Cloud Spanner for graph relationships, so and so on. So pretty much these are all the services we're going to be using on throughout the lab.
Yep. And while we're waiting, let me explain what is the solution stack for today. Because we talked about the challenge earlier, we haven't talked about what is the solution stack, right? So the first stack is how do we need to processing this multimodal data. So basically we want to capture the data and we want to convert the photos, videos. Remember the photo, you take a photo of yourself, you take a video of yourself, right? All those multimodal data, we want to process them to structured data. And the next thing is we want to organize in the search. So basically we want to do graph search, a graph rack, not only rack, and it's graph rack. And we're going to explain what is graph rack and how to do graph rack search really soon. Basically, you're going to able to search in this relationship and do intelligent search. And next, you're going to using ADK. ADK is Google Agent Development Kit. It's open source framework for you to build agent. We're going to use ADK to orchestrate the agent so that you're building a multi-agent system and that's processing this unstructured data. And next, last is the agent memory part, right? So you are uploading all those multimodal data. How does the system remember all the information? Everything, like you're uploading everything your search. How does the system remember, have the long-term memory, remember everything and have this personalization? And we're gonna touch memory, agent memory. So I'm gonna talk about that for the second half of this live stream. And yeah, okay. And I'm gonna continue for this GCloud service enable. So it looks like it's finished. I'm gonna continue to the next step. Next step is just to run setup script. So I'm just copy this command, and I just paste it here. So this step is to trying to create some environment, to create the .env file for you, and it's containing all the necessary variable for you. And if you couldn't find it, you can, so some of you, if you're using the Google Cloud Shell or editor, it will hide the .env file for you, so you can follow the instruction to toggle hidden file to open it. But most of the time you will see it, so let me show you. So once you saw this, it probably means that you successfully run it. So you will see, on the top left, I have this .env file, and I have everything here. So I have all the necessary variable here. And those are all you need for today's environment setup. So for some of you, if you notice anything is empty, if you saw anything is empty, that probably means that something's wrong. You can ask, watch your TA for help, or I'll send it to the group chat. All right. So next step is we need to use UV sync to sync our environment. So Io, do you know what is UV sync and why we are using UV to manage our environment?
Yeah, great question. So UV sync, essentially behind the scenes, we're using Rust, and it creates a virtual environment for you with all the packages kind of managed. So it's a more modern way of managing your virtual environments. So that's what we're using for the lab.
Yeah, so if you can see, we have this toml file to including all the dependency here. So by UV sync, you're basically installing all the dependency here. And now you can see that we have everything set up. And the last step, I promise you, this is the last step for your setup. And then we're gonna get to the fun part. So last step is we need to load initial survival data. So I will copy this and come back to this.
Yeah, so we want some data to work with. Yeah, so not to interrupt you, but overall, you said we're just loading some sample data just so we have something to play with in Cloud Spanner as we kind of go through the lesson. Yeah.
Yeah, that is a good point. So, Io, you mentioned about reloading the data, we are using a spanner. Can you maybe walk us through why we are using spanner for today's graph relationship data? We can just using the remaining solution, right? Why spanner?
Yeah, great question. As you kind of walked through earlier on, like the challenge for today, the survivor network. So we have a bunch of survivors on this planet. Some of them have skills, some of them have needs, some of them have resources. And how can you actually manage the relationships between all these survivors and their relationships? Like the one person has a medical need, one person's a doctor. Essentially, to do that, you would have to kind of maintain the survivor profiles. You have to maintain the relationship between all of that. And the way you would traditionally do that is having a Postgres database for the profiles. You might use Neo4j for the graph relationships. You might do ETL to kind of actually extract relevant data and create like a vector DB or semantic search. But with Spanner, you can kind of unify all that in all one place. You can do vector management in one place. You can do graph management in one place. So it's a really good production, standard for one unified database that kind of simplifies data governance, and that's what we're going to be using today. Yeah.
Sure, thanks, Ayo. And if you go back to this terminal, and you can see that we're able to create this spanner, and you will see this link, right? So I just need to click into this link, and then you can open Spanner, right? So if you click this link, let me share the right screen. Okay, this is Spanner. Okay, and this is in the Google Cloud Console, and on the top left, we have way back home, making sure it's picking the right project. And here, just on the left, just select Spanner Studio. So you can see we are loading all the data for you, right? And let's take a look at what are existing data. Because so at the earlier, like we talk about, multimodal data. We have like some people need food, maybe like me, I'm hungry. Some people on a treatment. Some people are good at engineer skill. Some people are good at medical skill and more, right? How do we store all those relationships? And let's take a look at what are existing data we have in by playing around this Spanner Studio. So let's go to our step 4, visualizing graph data in Spanner Studio. Again, if you find this is fast or you cannot follow, don't worry. You can always, pause the video and watch them. All right. So this step is you're opening the Spanner Studio, and you just try to copy this query to the Studio. So I'm just copy this, this graph thing, and then I'm just go back to my Studio, and here I'm opening a new tab on the right. So I just paste it over here and then click Run. And you can see, we have some graph here. Yeah, Ayo, please.
Yeah, so pretty much all we're doing is visualizing the question, where are the survivors? So how would you actually visualize that with this graph DB? As you can see, it's a pretty simple query, and immediately we can kind of see the survivors, with their biomes, and how they're connected.
Yeah, so if you hover on the node, you can see that the blue node is survival and the red node is where they are. So now you understand, okay, now we have 4 survival on this planet, and there's their location. So you start to understand the situation more. And next is I want to understand what are their skill. I have 4 survival, what skills they have. So I just copy this and go back to my Spanner Studio. You can open a new tab or replace the existing one. So I just open a new tab and paste it and click Run. So you can see that, I can notice that like some have 3 skills and some has 2 skills, right?
Yeah, some are really talented. Yeah,
like
but overall, as you can see, overall, you can kind of see it's a really easy way of visualizing what are the graphical relationships. And again, we're doing this all with Spanner. So, and later on, we're going to add vectors to this as well, and then do semantic search alongside it. So it's a really powerful tool in DB.
Yeah, and similarly, next one is let's understand who's in crisis, who needs some treatment. So I just copy this and then coming back to the table and then place it. So you can see, okay, so those are their need. So they need some technical, they need some medical. Some people need some science. They want to learn more science. And I'm gonna coming back to this. And the last one is I can see what are the existing match, exist. So maybe some people, maybe they already have some existing relationship in this graph database. So I'm just coming back to this. And then again, I just paste it. You can always open a new tab and run. It's the same thing. And yeah, so here we have the 4 survival and the skills and the need. And you can see that we have the edge between the skills and the needs, so that there's a potential, match, this skill can help this need, right? So this is also, remember earlier we have the 3D rendering thing on the screen, right? So that is a 3D version of our existing data. And later on, if you're uploading new multimodal data, and we will update this graph in real time, and then the graph on the screen will also update correspondingly. Cool. Okay,
Yeah.
sure.
Nice.
Yeah, okay. So next
Let's move on to the next step. Yeah.
Okay, great. So next one is we want to talk about like embedding in Spanner. Just like we mentioned before, we want to learn AI in Spanner. So before we do things in Spanner, let's take a look at this graph. You know, it's a lot of things going on this graph. But I suggest you take a look from the bottom to the top. So the bottom, we have, we're creating this text embedding model and Gemini Pro model in Spanner. And at a service layer, we are using this embedding model in the RAG, in keyword search, in the hybrid search. And then we have the tooling layer that connecting our service so that tooling has a complete logic. And then we have the agent layer so that agent can connect into the tools. You know, essentially, agent is like we have model as a brain and we have a tool, tools in the toolbox, and model as a brain gonna reasoning and pick the tool to solve your problem, right? So you need to attach the tools to the agent. So we're gonna start all the way from bottom to top. But why we are creating this model in DB, because we can just directly using this model in service, in Python code, right? We can just create it in Python code. Why we want to create this model in DB?
It's just efficiency. Imagine having to spin up a Colab notebook. You're importing all these packages so you can first pull the data from Spanner. Then you're calling these models, creating the client constructions. The nice thing about Spanner is that you can essentially create the model definition directly within the DB. You can create the embedding definition for the embedding model directly in DB, and then you can call it directly in the DB. So it's parallelized, it's more efficient, faster outputs. So that's essentially the benefits of Spanner. So not only can you do things like embeddings and store the vectors, you can actually generate them directly in the DB as well.
Yeah, so for those of you who don't know what is embedding, basically embedding is a numeric representation to explain, to describe certain things. And Google just have this, recently have this new model that we have this new model that can convert all the unstructured data, the multimodal data, to embedding in our embedding space. Yeah, Ayo, why don't you explain more in the embedding? What is embedding and what is this new model about?
Yeah, so how can you do things like semantic search across different types of data? So not only can you embed textual data and create vectors of that, you can create vectors of images, video, audio, documents. The benefits of this, if we're working with SOS signals, so you can imagine some survivors are going to leave messages like on trees or like on the floor because there's no one around them. So not everything's going to be text. You can still kind of convert these multimodal data to embeddings, store them in the same vector DB, and do semantic search against them. So that's really the power of these multimodal embedding models.
Yeah, that's a great explanation. And next, let's just follow up, like just enforce on what is semantic search and how to do search in the embedding space. So basically, first you're using this embedding model. You just show that you're convert the object. It can be like image data or text data or video data, and then we get embedding from this things that we want to curate from. And then we have this embedding space. Basically, it's containing all the embedding. And then I want to search for when I do the curate. I want to search in this embedding space what are the things that closest to the things I want to curate from. And then for the things that's closest, I want to like rank them. So that is basically the basic of semantic search, and it's also what we want to do for today, because in today we want to like generate the embedding model in Spanner, and then we want to generate this embedding space. We want to generate this. So that every time we query, we can just generate embedding and search in this embedding space.
Yeah, and what you think about the reasons why our survivors may have different languages. One might be speaking English, another speaking, Spanish or a different language, or let's say I'm looking for someone who has first aid skills, but I don't want to use the exact keyword first aid to find my answer. Let's say I want to find someone who has medic skills. You want to be able to kind of convert all this into the same normalized embedding space. So you can kind of get results ranked, as you mentioned, regardless of how you phrase it. So that's kind of the benefits of semantic search.
Great. So now let's come back to our lab to see how to do that. Now we know the theory, right? We need to now actually do this in embedding, just like what we mentioned before. We want to create embedding in Spanner. So the very first step is you want to create this text embedding, and this is a place that people make mistake most of the time, because a lot of the time we forget to, when we're trying to create embedding, we're not using our real project ID. So I have this instruction here mentioning that, remember earlier, we have this, we're creating this .env file, right? So this .env file has its project ID over here. So if you probably wanted to keep it open, or if you have this Google Cloud Console, and you will have this project ID over here. So yeah, there are multiple ways of finding the project ID, but it's very important that when you're first creating the embedding in Spanner, it's important that you replace this placeholder to the real project ID. Otherwise, you will have the issue when you use this model. Okay, so I'm just copy this, and then I'm coming back to my Spanner Studio. Remember, those are the things we created before. So I just replace this, and I need to replace my project ID with a real project ID. So here I just copy. I'm gonna copy this project ID, and then I'm coming back, making sure that you also replace the $sign. You know, some people forget about replacing a $sign, so that's still not working. So now you can see that I creating this embedding, and then I'm using the real project ID over here. And then if you see updated complete, that means you successfully create an embedding model. Yeah, please, Ayo.
Yeah, and if you remember in the beginning of the lab, we enabled the AI platform Google's APIs. So this is the reason why we did it. So now we can actually start referencing the models that are available at these APIs. So, and going back to what we mentioned earlier, so rather than opening up a Colab notebook, we're essentially creating a pointer directly to the embedding model directly in Spanner using about 5 lines of SQL code. So that's the nice benefit.
Yeah, so we are going to use this embedding later on with this ML predict, so that we can directly using this model in Spanner, but we can talk introduce that really soon. But first, let's create this embedding. And then next thing is we want to add this embedding column, so that later on I can generate this embedding space. You know, we want to generate, so right now I want to search all the skill related to medical, because I want to find people who has medical skill to help with the emergency need. So I want to convert all the skill to embedding space and search in this embedding space, right? So right now I'm just, so first I need to create a table skill, and then coming back to it, create this table. And next is we need to generate embedding. So this is a step that we're using the text embedding model, right? So Ayo, you can explain, you know, why we are using ML predict here to generate the embedding in Spanner.
Yeah, so ML predict is essentially just the Spanner syntax for essentially invoking that embedding model that we defined. So essentially it's going to be calling that model behind the scenes, and essentially we're converting the skill name into what we're embedding. So essentially we're creating a vector representation of all the different skill names. So like one person may have medic skill, another person may have first aid skill. So essentially we're just creating representations of that.
Yep. And next is we creating this embedding space, right? So we just have this embedding space of skill. And next is you want to verify this embedding. By first, you want to check this embedding dimension. Dimension, basically, you want to have all the different angles to describe this information. And here, the dimension is really depends on what embedding model you're using. So here, we just copy this and paste, and you can see that embedding dimension is 768. And here, we generate those skills. And the next one is we want to test, do the test of semantic search. So this is basically, I want to search something, medic. I want to get the embedding of medic first, and then I want to do the search, do the semantic search to find. So basically the query is that first I want to get embedding of the medic, and then I want to search in this embedding space, and then trying to find the things that are similar to embedding. But why we are using call sign here to calculate the distance?
Yeah, great question. So when you're doing semantic search or vector search, you want to make sure that you're using a distance function that actually is like optimal for, you know, RAG, or retrieval augmented generation. Cosine is oftentimes used for RAG because it essentially does more of a similarity distance rather than just magnitude distance. So rather than using something like Euclidean distance, cosine is better at actually finding more of an alignment from a semantic standpoint. So most of the time in RAG functions, you tend to use cosine distance.
Yeah, and you can see that now when we do semantic search, you can find things ranked by the distance. So the closer, the semantical training and first, even though that they're not the keyword exactly match our since we want to query magic, but this for the meaning they're actually very close to magic. For things that's further very like leadership, it's not similar to magic at all. So now we verify that we successfully create this embedding and then do the semantic search. And for some of you, if you have some error at this stage, you probably have issue, creating the embedding model. So you probably need to go back to the embedding and then just drop the model and redo it to making sure you create a correct embedding. So now we have this embedding, and next is we want to create this Gemini Pro model. Similarly, similar to create an embedding model, we create a Gemini Pro model here, and also you need to replace this project ID by the real project ID. Otherwise, it doesn't work. So just place here, and then making sure I create the correct Gemini Pro model, and I want to verify this model. Over here, basically, I'm using Gemini Pro model with ML Predict, right? And this is a prompt I sent to the Gemini Pro model. Basically, I want to access the capability of truth survival, and then I want to give the score. I want to use Gemini model to generate a score from 1 to 10. So I want to see whether I want to use this to test whether I successfully generate this Gemini Pro model. So I just copy and paste over here. So I would expect to see a sentence that or like a score from 1 to 10 if I successfully generate this Gemini Pro model.
So essentially what we're learning here is like two different ways of doing similarity analysis directly in Spanner. So one was using the embedding model where we did semantic search. And another thing that you can do is just pass in the actual data itself into the model and have it do an assessment. So you can do an embedding model kind of semantic search, or you can use Gemini for more of a semantic analysis as well.
Yeah. Thanks for explaining. And for today, we are going to do semantic search. We're going to do the RAG, but later on, when we ingest the multimodal data, even though we have this amazing multimodal data model, but we're gonna using Gemini Vision API, basically Gemini 2.5 to understanding the video information. So yeah, that's basically what I mentioned, that there are different ways of understanding data. So now we have this. I'm gonna share this tab. Okay, sorry, it's this one. I'm checking this is the one. Great. So what we've done so far is we have this model created, right? Text embedding model. We have this Gemini Pro model, and next thing is I want to, implement my service layer using the text embedding model so that I have the semantic search capability, and then I can grab that as a tool so that my agent can use it. So whenever I ask a question so I ask this agent question, oh, who has this magic skill, or who can help with this injury, I'm expected to use one type of search, and then if it's semantic search, it will use the rec search, and then it will use the embedding model I created over here. So now let's get to the lab. So here I am at my step 6. You want to build your RAG agent. So first, as I mentioned from this diagram, that you want to go implement your service code. So in the service code, so first you want to open this service code file. So what I do is I copy this code, and then I go back to my Cloud Shell, and I'm gonna paste it over here. So this command basically is opening this file. If you don't run this command, you can directly search this file, right? So I'm at this service file, and I want to locate this to-do. I'm gonna share this. So I wanna locate this to-do. I'm coming back to this, and then I want to copy this to-do to with this query. I wanna do the search. So basically here, I am.
Make sure you switch. Yeah.
Okay. Yeah. So here I just replaced the placeholder with a real implementation, And let's take a look at this implementation, right? So yeah, so Io, maybe does this look familiar to you? The SQL?
Yeah, yeah. It looks pretty much like what we were running manually in Cloud Spanner. So it looks like pretty much all we're doing is we're creating like a more of an automated service that kind of invokes that same logic that our tool is then going to call. So agent tool service. Yeah.
Yeah, but no, realize that we actually is a slightly different, that we have some join thing over here, right? So this is actually the magic of graph search, graph rack. So because we are talking about the graph rack today, and then how does a graph rack different from traditional rack, right? So when we ask the question, find a medic for this victim, and then if you're using the embedding model, we generate this embedding first. And then, so normal rack is retrieval. So before, in case people, you forget about normal rack. So normal rack is retrieval augmented generation. You're doing the retrieval first. Retrieval can be semantic search, and then you search in the vector database. And once you get the result and you do the augment, so you augment to the existing LM knowledge, and then eventually do the generation so that you generate the knowledge based on your personalized database, right? So that's it. Traditional rack. So for a graph rack is instead of directly augment and generate, you do this graph traverse. So here, if you just simply search the skill, you don't know. So in the traditional, you only search the skill. But here you can traverse the graph to know who has that skill, so that you know what is the person had that skill to help. So that with LM context, you can get more information by traverse the graph and to do more efficiently gathering the result. So that's the power of a graph rack. And to implement that is you're making sure when you implement the logic, you need to join the table. So now we have the service layer code, and then we want to making sure the service layer is wrapped in our tooling side. So again, I'm going to copy this to the tool, and again, you can just open the tool file if you don't want to run this command. And next thing is I want to search for the placeholder. So I'm search for placeholder, and then I want to copy this logic over here. So basically you're wrapping the implementation you have in the service layer. So once you, okay, I forgot to share the screen. So basically I copy this here, and now, so what I did before is I finished the service layer, I finished the tooling layer, and now I want to attach this tool to the to this agent. So basically, we need to making sure first we update the system prompt to include the logic of how to using this tool, and then we want to add this tool to the toolbox so that agent will follow the instruction and using the tool correspondingly. So now we need to go to the agent layer. So I just copy this, and I'll paste it to the chat so that I open the agent file. And next is similarly, we find this to do over here, and then I look for things to replace, and then just copy this system prompt so that now I can instruct my agent to do search correspondingly. And coming back, I will adding this tool to my toolbox so that agent has this tool to make a decision.
Yeah. So to summarize, what we've done so far is we created a RAG service. We wrap that RAG service within a tool. We're now passing that tool to an agent, and then you're instructing that agent when to use that tool, pretty much.
Yeah.
Yeah.
Exactly. Thanks for the explanation. And
a quick question: could you explain, like, so we have different types of search. So we have keyword, semantic, hybrid. Why is it necessary to have 3 different types of search? Yeah.
Yeah, so that's a really great question. So if you take a look at this slide, that we actually have different type of search, like we mentioned. What we did before is semantic search, right? So semantic search is I want to find things that are similar to the meaning I'm searching from. We also have keyword search. So keyword search is really powerful in the case that you want to search a specific arrow code or specific location with a code. And then, so if you're using semantic search, you cannot find exact result. So that's a situation that keyword search is so helpful. But what if, there's a case that you care both the meaning and the keyword? So for example, I want to search for medical skill in mountain. Medical skill is medic is things that anything similar to medic. But mountain, maybe I want to have a specific location code. So in this case, we want to using hybrid search. But how to do the hybrid search? Io, do you know?
Yeah, great question. So essentially, you have to kind of rank. So essentially, you do both semantic and keyword, and then you rank and you do a weight kind of scoring of both of those results. So you tend to get more accurate results than with either by themselves. So essentially, this is the algorithm that we're using for today. But there's different weighting algorithms that you can use. But overall, hybrid tends to give you the best results. Yeah.
Yeah, so this is the RF algorithm that you get the result from keyword and get the result from semantic, and you calculate a new score. So this is one way to calculate. Just like I mentioned, you can also just simply calculate the weight, but RF is often used for hybrid search. And if you take a look at this lab, that you do not have to implement hybrid search yourself, but we have this logic already implemented for you. And if you're interested, you can go look for the code, and this is how we calculate the new score and do the ranking on RF score. All right, so now we just build this graph rag agent. Also, another thing is Spanner also support hybrid search. So you can actually write the query in Spanner to do a hybrid search in Spanner. And here we're doing the hybrid search in Server. So it's really a design choice for you to do it. Okay, so now we are finishing our service. Let's just do a quick recap of what we've done so far. So far we created embedding, and we created a Gemini Pro model in the Spanner. And later on in the service layer, we are using the embedding model so that we implement the semantic search and all the logic. And the tooling layer, we are attached to it. So that now in the root layer, if I want to ask questions, if I want to search exact search, I want to search a specific location, and then so more Gemini as a brain gonna decide, okay, I'm gonna use a keyword search, and then you will just search by exact match. And then if I'm searching for things like who can help with emergency or what is a medic, I will probably expect AI to decide to use a semantic search tool, and then use a semantic. We were using semantic search that we're essentially using a text embedding model we created in the Spanner. If you're searching in the hybrid scenario, basically medical case in the mountain, and then you'll probably using a hybrid search. And let's take a look at whether we successfully built this in ADK Web UI. So now I am at step 7. I want to test my agent with ADK Web. So all you need to do is just do ADK Web. Here I have the UV just so that I can control the environment. So I know that we also have some other way of running ADK, right?
Yeah, so ADK is essentially ADK development kit. It's an agent framework for building, deploying, testing agents. And with ADK, there's different ways you can essentially interact with agents. You can do it directly in the terminal with ADK Run. There's also ADK Web, which we're spinning up right now, where it essentially gives you a development kind of testing UI, where you can kind of prompt the agent. You can kind of see the direct traces that get output. So I tend to like the ADK Web, but ADK Run's really good for like you want to do things directly in the terminal as well.
Yeah. And so now when we do the ADK Web, you can see we have this port. You can directly click to it, or you can just do web preview and change port to 8000 and change and preview. So either way work. So if you type this, you will see that we have this ADK Web UI. I'm going to zoom in so that's clear to use. On the top left, you need to select the agent you want to test. And coming back to this, I have some example for you to test. You can just ask questions like, who can help with injury? So let's try this question and coming back to this. So behind the scene, I was hoping AI going to decide using the semantic search and to search things that are similar to medical, and then do the graph rag, do the graph traverse to find who has that skill. So now you can see that I'm using the semantic search tool and then get the search results, and then here I find that those 2 persons can help with the medical thing. And here you can see in the ADK Web UI, you can just you can see all the graph of relationship with the agent and tools, and all the parameters passing to the tool. Pretty cool. And if you're interested, you can try different query and just test your agent is working as expected. So now we have this agents working, right? Now we know the agent is working. But remember earlier, I shared this whole application. So how do we connect this agent to our application? Nowadays, a lot of companies want to build agentic solution, but you need to decide, what is the feature that is agentic and what's a feature you do not want agentic. How do you connect the feature that need agentic feature, right? So here it's a reference for you, and I'm gonna pass it to Io to explain this full application architecture and how we connect front end to back end, and how we build a multi-agent system. And Io also gonna talk about agent memory, which is really cool. So Io, why don't you share your screen?
Yeah, so I'm sharing my screen now. As you can see, so right now we're essentially going to learn how can you convert that, development agent that we just tested in ADK Web and convert it to a full-blown application where you have a front end, you have the agentic backend, and you have things like session service and memory service that's maintaining state in memory. So we're going to learn that now. First thing that we want to do is essentially connect our in-memory services for session and memory. So let's go ahead and do that first in the lab. And I'll walk through what session and memory means, but let's first update this in the Cloud Shell. So the first thing we want to do here is copy this. And then I'm going to come over here to the Cloud Shell. I'm going to open my Cloud Shell now that I'm coming here. I'm going to authorize.
Yeah, maybe you need to zoom in because it's very small for me.
Okay, so it's going to navigate to the file. And since I'm spinning up my Cloud Shell for the first time, it's going to be a little bit slower. Okay, so here's the chat.py that we're editing. So essentially, this is our backend definition for our agentic service. So we have our API router. We're using Fast API for the direct backend invocation. We have our API keys that we're using for Gemini. We're going to talk about memory bank later on. But overall, all we're doing now is we're establishing what we call in-memory session and in-memory memory. So essentially, when you call this service for the first time, anything that you do, like let's say you close the application, it's going to that memory is going to go away. If you want to actually make it persistent, that's when memory bank and what we call Vertex AI memory service comes into place, where essentially you have persistent sessions, you can come back to it, you have user profiles that kind of retain over time. But we're going to learn that later on. But let's go ahead and create our in-memory definition. So I'm going to copy this here and paste this here in the Cloud Shell. And make sure that your indentation is correct. And next thing that we're going to do is we're going to establish the runtime for our backend agent. So when we say runtime, I will kind of share the screen here as well. So essentially, when you use something like ADK, behind the scenes, a runner is kind of instantiated. And the runner is essentially that manages all the events that the agent sees. So when the agent is calling a tool asynchronously, or when it's updating state or updating memory, all that runtime is being managed by the runner. And there's a lot of things that you can do to configure it. But all we're going to do now is essentially pass in the in-memory session and in-memory memory that we just defined earlier. So coming back over here to Cloud Shell, we want to come down here and then make sure to paste in the runner. So here's our runner definition for our backend service. We're passing in the root agent that we just tested in ADK Web. We're giving it an app name, Survivor Network, and essentially we're just giving it these in-memory services that it runs while the app is up, but the minute you spin down the app, all that memory is gone. So that's obviously not good for production, but we're going to learn how we can kind of make it persistent later on. So I'm going to go ahead and save this here. And now that we've defined our runner, we can actually go ahead and start our backend service and see how it works. So I'm going to go ahead and copy this here. And overall, when it comes to the connection between the front end and the backend, our front end knows how to communicate with the backend via the local endpoint. So that's pretty much it from there. And our front end is going to be running at localhost 5173. So I'm going to go ahead and copy this here and come back over here to the terminal and paste this here. And it's going to take maybe about 20 seconds for the front end to spin up.
Thank you. Yeah, so what does behind the scene is first it will start a backend server, and then you will do npm run dev to start the front end for you. And this is just a script for you to quickly start the application. And I noticed that you put the in-memory session service and in-memory memory service. What does in-memory mean?
So essentially, it's being stored locally in RAM. So there's no database that's connected with this memory that's coming from the session that we're going to kick off. So as mentioned before, while you're testing the app, all that session is going to be in memory. The minute you close the app, so let's say you close this local server, that's going to be gone. So it's good for development and testing. But if you want things to be persistent for production, you want to use like, remote DBs or Vertex AI session service or memory bank, which we're going to talk about later.
Yeah, cool.
So now that we have our endpoint, essentially we can actually go here to web preview in the top right corner, change port, and make sure that you put the port number matching the front end. And so change in preview, and you're going to see this front end app spin up. So it's loading the survivor network. Make sure that you click retry and that you share your camera with the screen. I'm going to go ahead and do that now.
I can't wait for you to control the
yeah.
The graph. And yeah, if you see the graph on the top, it's actually all the relationship we have in the graph database. And I was controlling the planet.
Yeah, so it's just a multimodal interaction. So how could you visualize the actual graphical relationships between the survivors? This is just a fun way of doing it. But now that we have our app, we can essentially prompt our mission control AI the same way that we were doing in ADK Web. So I'm going to come down over here, and just to confirm that everything is still working the same way it did, I can copy the same similar question that we tested in ADK Web and come back over here to the front end and paste the question. Find skills similar to healing. So the agent is being invoked, and you can see that immediately it gives me skills that are similar semantically to healing, first aid. It's giving me the matching score, the category of that skill. So everything seems to be working. We can do one more that's more of a hybrid question. So again, as Annie was mentioning, sometimes you want to have constraints to your search. So medical skills should be semantic. Let's say you only want to find this where the keyword mountain or keyword medical is mentioned. That's when you would have something like hybrid search come into play. So let's go ahead and test this question as well.
Yeah, so I was hoping the Gemini can identify the need and then follow the instruction to choose the right tool, and then it will select the hybrid search tool or semantic search tool to grab the result.
Yeah.
I think the result is here, Io.
Yeah, great. So we have the result that was output, and as mentioned, it's doing a little bit of both, where it's, again, hybrid. So it's using keywords medical and mountains. That's a good extraction. And then it's doing the query contains a specific filter medical, which is ideal for keyword search. However, the location mountains does not have a direct match in the available biome. So that's still a good result. And then it's giving us what kind of matches what was able to find amongst that DB. So really good outputs, and it knew when to use hybrid in that particular scenario. So that's pretty much it for testing our app here. But overall, as you can see, we're doing a lot of text prompts. But when it comes to SOS signals, as we mentioned before, they tend to be more multimodal in nature. You may take a video of your location. You may leave a note, somewhere, so someone can find it. So we're going to learn how can we now make this agent multimodal, so it can process multimodal inputs, multimodal SOS signals, and that's our next step.
Yeah, I'm curious, how do you design a system that you can, not only take the user's query, like search this medical skill, but also understand the multimodal information? What is the design we're gonna have for this one?
Absolutely, we're going to learn that in a second. But just for before we kind of move on to the next step, for anyone that is who did level 0 and level 1 and wants to kind of see their location update on the map, make sure that you run this last command here, and it's going to make sure that it kind of establishes you at level 2. But again, if you haven't done levels in level 1, you can kind of just ignore this. So let's proceed. So as Annie was mentioning, so how can we design a pipeline that essentially allows us to process multimodal data as part of our agentic system? And essentially what we're going to be building behind the scenes is multiple layers of things, but we're going to be building, long story short, that's what we call a sequential agent. So there's different types of workflow agents in ADK. There's parallel agents if you want to have agents running together at the same time. There's loop agents if you want to have a workflow that runs up to X amount of times. And then the sequential agents, sometimes you want there to be a certain process behind how agents are called. I want agent B to be called, then agent B, then agent C. In our particular use case, we have a particular process behind our multimodal processing. So we're going to be using a sequential agent. So specifically what we're going to be doing is we're going to have a multimodal agent that's going to be the workflow agent, sequential. And behind that scenes, that multimodal agent is going to be kind of queuing up different agents. So we're going to have an upload agent that kind of processes the uploaded multimodal data. So it could be an image, it could be audio, it could be video. We're going to have an extraction agent that essentially extracts meaningful structured data out of that multimodal data. And then we're going to have another agent that's kind of responsible for then updating the DB with the extracted data that we were able to get from it. And then lastly, when it comes to something like memory, we're going to have an agent that actually summarizes everything that was just processed, so that if we want to store that as part of memory, that's going to be available in a summarized fashion for us to do so.
Yeah, I also want to add that currently we're using this multi-agent as a solution, but you do not have to build this multi-agent as a solution, because you can just have a different pipeline to processing image and processing text, and then eventually merge them. But when you merge them at a different pipeline, it's going to be a mess, because you have many things to manage. Or you can have event-driven architecture that, for example, you're uploading all the multimodal data to storage, and then you're triggering the PubSub topic, and then then later on you want to extract things, and then you more function, and then you update the spanner. So it can be very complex if you're using event-driven architecture. But so essentially it's a decision that we can use in multi-agent system to build that, because with a sequential, we can definitely run them in a sequential order. But why we're using a sequential workflow? Because you mentioned that previously we have parallel, we have a loop agent, and then we have like a hierarchical pattern, and why we're design a sequential in this case.
Yeah, just to summarize what we're building here. So here's kind of the end-to-end flow. So imagine your prompt now is, I have a supply of medical supplies that I found, or here's an SOS signal that I found, out in the wild. You want to be able to pass that to your root agent, which is then going to call the multimedia agent, which is then going to invoke these agents in sequence. So the upload agent is going to be deployed to Cloud Run. Essentially, it's going to upload that multimodal data to GCS. The reason why we're doing that is it's not technically possible to kind of pass multimodal directly between delegated agents, but what you can do is essentially upload to GCS or Google Cloud Storage and pass the reference to that image or multimodal data via cloud storage. So essentially what other agents would see is that cloud storage URL. And then essentially that extraction agent is going to grab that URL from state. It's going to then call a tool that behind the scenes is using Gemini 2.5 Pro or Flash. It's going to extract structured data from that multimodal data. So let's say from the supply of medical supplies that you uploaded, one's a med kit. You see there's 5 different quantity of that med kit. The location from that image is apparently warehouse B. All that's going to be extracted as part of that tool. And then again, we're going to have another tool that's going to be managed by a spanner agent that's going to actually then interact with our DB and make sure that we're updating the graph in the correct way. And then lastly, as mentioned before, we're going to have a summary agent that's being powered by Gemini that summarizes that entire output and process. So let's go ahead and see how that's being built. As Annie mentioned before in the lab, for these parts of the lab that don't have the rocket sign, this is really more optional. So you don't really have to code anything, but you can kind of walk through the lab and see how everything's being built. So let's go ahead and do that now. So when you take a look at the extraction tools, actually, we don't have to necessarily go through Cat Shell. We can actually just walk through it here. So when we talk about the extraction tools that our upload agent or extraction agent is going to be using, we can see that this is the underlying function. So essentially, upload media is the function call. It takes the file path from GCS, whatever survivor ID that's associated with that particular file path. And then all we're doing is processing that file. We're storing some metadata about it, and then we're returning the function call. Then lastly, when it comes to the extract from media tool, that's going to essentially be calling that. All we're doing is extracting the media type, so image, text, or video. And then we are confirming the extraction result, any entities that were extracted from that, any relationships that were extracted from it. And then we're making it available via a dictionary for the next agent in line. So again, whenever you call these agents, essentially they interact with each other via shared state. So this is kind of like short-term memory for agents as opposed to long-term memory, which we're going to be talking about later on. So it's essentially like a scratch pad for these agents. So as so go ahead.
When you say short-term memory now, long-term memory later, what is the difference between short-term memory and long-term memory in our context?
Yeah, so when it comes to short-term memory in our context, it's essentially just like the existing state. So essentially, when these tools return this, this output, status success, extraction result, is going to be stored as a dictionary as part of our state. And state is essentially just existing for the current session. But if I were to essentially refresh my session or create a new session, any analysis that I was doing against that particular survivor or that region, it has no memory of what was done before. But if you want to actually extract semantic relationships and meanings out of like certain things that you've done in the past, you can use long-term memory, or what we call memory bank, for that. We're going to talk about that very soon. But it essentially allows you to have insights that are being shared across multiple sessions.
Yeah, so right now we are having this live stream, you're listening to us, we are having this conversation. It can be like one session, and once you close it, you forget about what we talk about. So that's like in-memory short-term thing. And then if you can stay this conversation or store this somewhere in the database or on cloud, so you can always coming back and then understanding, what is this conversation thread. That's probably the long-term memory we talk about. So just want to make sure we're on the same page, and what we're doing now. We're doing the in-memory session, and later on we're going to do what has AI. Basically, you want to store everything on cloud.
Exactly, yeah. So again, and just to emphasize what you just said, why long-term memory matters. Essentially, you want to be able to remember past conversations, past survivorship analysis that you did, and using long-term memory allows you to do that. But let's kind of go ahead and proceed through the rest of the lab. So we kind of just defined the different functions that we're using for the previous agents, such as extraction, uploading. Again, here's what our spanner agent is going to be using behind the scenes when it's being told to save some data. Here's the underlying. Here's the underlying function call, where essentially it's saving the status, it's saving the entities that were created from that, and then essentially it's invoking that spanner service behind the scenes to actually save the extracted data. So again, that's our end-to-end workflow: upload, extract, then call the spanner service to essentially save the extracted results. And that's pretty much it from that particular pipeline. And we just talked about this from a tooling perspective. From an agent perspective, it's very similar. Well, essentially, we're creating different agents using ADK syntax. So we can actually walk through that this time. So we talked about the tools that we're creating for this particular upload pipeline. But when we take a look at the agents, it's very similar, but let's look at it more from an agentic angle. So I'm going to go ahead and copy this here and paste this here in the Cloud Shell. So coming back over here. So all these agents that we're creating, oops, I copied the wrong thing. Let me make sure that I copy the right thing. So essentially just going to open up and, sorry, looks like my copy is not working. One more time. Okay, perfect. So all these agents that we're creating follow a very similar syntax that are being via the ADK. So essentially, here are the agents that we're creating from google.adk.agents, import agent, import the workflow sequential agent, and import LM agent. LM agent is pretty much just like an alias of agent, so you can use either one. But here's our upload agent definition. LM agent, we're giving it a name, a model. When you're creating an ADK agent, you can use Gemini models, often by default. But if you want to use open models that you've self-deployed yourself, you can actually do that as well. So you're not kind of limited just to Gemini models when you're using the ADK. We're giving the agent an instruction. And again, we're passing in the tools for that agent to use. So kind of going back to the tools that we just defined, we're passing in the upload media function to the upload agent, and that's pretty much it.
Yeah, I also.
And then we're defining.
Oh, sorry. So also. Oh, sorry. So also we have the output key equal to upload result. So that's basically how agent communicate with each other. We communicate with session state. So you want to output all the results from the upload upload agent, and then you want to output the result and then save it to a key value dictionary. And the key is upload result, and value is the real output. And you will pass that to this extraction agent. So now in the extraction agent, you can see that we have this curly braces in the prompt. You can mention, like you can highlight. Oh, yeah. It's here, and then you can like pass it to the extraction agent, and then an extraction agent gonna, based on your upload result, and gonna do the analyze, and then later on you will continue on update the spanner later on. So that's how agent communicate with agents through session state. And if you specify this key, you have this dictionary, so that they can easily communicate with each other, right?
Exactly, yeah. So essentially, pretty much session state is essentially a dictionary in memory that all the agents have access to. And the nice thing about the ADK, as Annie just mentioned, you can dynamically kind of specify state variables that you know exist for other agents down the pipeline. So our extraction agent is automatically assuming that there's going to be an upload result when it's being called, because again, it's going to be in sequence. So by the time upload agent is finished, our extraction agent should have access to that state value. Very similarly, for our spanner agent that's saving the results in the DB, it's assuming that there's going to be an upload result state value as well as an extraction result state value. And then it's going to be invoking that save to spanner function. And that's pretty much it as far as our agentic definition goes for the individual agents. Then as far as the sequential agent looks like, again, it's just a sequential agent. We're giving it a name, a description, and that's pretty much it. And let's proceed with that. So we're actually here at this point in the lab. Make sure that we're in multimodal agent. And this is our multimodal multimedia agent. So that's where we're here. And we want to make sure that if you want to continue on with the rest of the lab, make sure that you actually put in the sub-agents value for the sequential agent pipeline. So what that looks like, again, is just defining the agents in sequence. So we have our upload, extraction, spanner, and summary agent. So let's go ahead and do that here.
Yeah, the order also matters, because if this is a sequential agent and one task is dependent on another, if you have them in a different order, they will run in a different thing. Usually, if you have the sub agent, the order doesn't matter, but sequential agent is special.
Yeah. And let me just okay. And coming back over here.
Have you shared the console? I don't see.
Oh, sorry, you didn't see. Yeah, so all I did was, again, I like to put it behind the to-dos, but you can remove the to-do as well. And here's the sub-agents definition that has the agents defined in the exact order that we want. So that's pretty much all we're doing there for the orchestration. And then scrolling down, next thing that we want to do is actually then make sure that our root agent has the ability to invoke the multimedia agent. So all we're going to be doing now is very similar, is defining a sub-agents parameter for the root agent, and then passing in the multimedia agent. That's essentially the whole workflow agent that we just created. So let's make sure that we open up the agent.py file. So again, you can navigate to it directly in the Cloud Shell or via that command, or you can just go to it in the editor. So I'm going to go ahead and do that here. And I'm going to find the add sub agent command and make sure that I specify this here.
Yeah, so now you have this delegation, like a routing pattern, so that whatever input you have, if this is a search, it will directly using the tool to do the hybrid search or semantic search. If this is the uploading case, if you're uploading any multimodal data, image or video, it will delegate, it will say, okay, now it's uploading case. I'm not going to using my tool, so it will delegate to this multimedia agent, and the multimedia agent gonna having this pipeline to processing the data.
Yeah. So now that we've defined our multimedia pipeline agent, as well as and we've given the root agent access to it, we can actually go ahead and test it. And when we talk about multimedia data, what we're going to be testing with are these images that you can kind of see here in the lab. So there's different test photos that you can use, and essentially they look like this. So we talk about multimedia SOS signals. You can imagine someone leaving a field report behind, or you might find an image of someone's profile. We're going to be attaching this to the model and see what it comes up with when it comes to reasoning. So let's go ahead and prompt this. So coming back over here, we want to now go back to the terminal and start the app. And again, it's going to kick up the front end at 51734 port. I'm going to go ahead and copy this here, open the terminal, and paste this here.
Don't forget to share your terminal.
Oh, thank you. Yeah. So all I did was paste it here, and it's not running. So I'm going to come over here. Again, retry here. Perfect. And I'm going to go ahead and test the prompt. So here's the survivor note, and then I will attach the test image. So let's use perhaps. Oh,
by the way, I cannot share what image you upload. Oh, okay.
So
I can see it.
Yeah. So yeah. I just pass it to the model.
Yeah, so I'll expect it. Oh, please.
Actually, so since I'm using a testing account, I may not be able to upload multimodal data from this particular account. But for anyone who's following along, you should be able to do that without an issue. But let's just see what output it comes with. It should say something like, I don't see a note.
Yeah, so while we're waiting for the output, we can just, have a quick overview of what we have so far. We're building, Io, if you can share this, or if you can see my screen.
Yeah.
We have this root agent, that root agent connecting to the different tools that whenever you do the search, you can, using the different tools to do the search. And if this is uploading, like I just demoed to you, it will delegate to the multimedia agent. And multimedia agent is a sequential agent, and it will run this process from left to right and making sure that every time I'm uploading and I communicate through the session state and I'm passing the result. And eventually I have a summarize agent to summarize the result. Also, why we are using Gemini API for extraction, not using the embedding model for extraction?
Oh yeah, the Gemini model is inherently multimodal. So when it comes to processing different types of multimodal data, we want to use the Gemini model for universal extraction. So that's the benefit of that. Yeah.
Oh, great. Yeah, I'm going to pass it to you to maybe we can talk about the memory while we're waiting for the result, or.
Yeah, absolutely. So the result did get generated, but as mentioned, I'm using a testing account that's actually blocking me from uploading the image right now. But for anyone who's following along, please feel free to do it. And actually, it uploaded just fine. So that's great. So I thought I was going to be blocked. Yeah, so it's actually processing that image. If you recall, what I uploaded was, you can actually see the image, but it's very similar to the image that's being shown here. Scrolling a little bit higher. So I uploaded this report that has a field report of past, actions. And it's telling me what it saw. It states that there's an energy crystal found in the bioluminescent forest by agent David Chen. It's giving me the person's profile, relationships found in the graph database based off of that image. So essentially now we're going from multimodal input to graphical outputs and insights. So that's the nice kind of benefit of this particular solution that we built. So that's pretty much it from there. So let's dive into agent memory, as Annie mentioned.
Yeah.
So scrolling over here
is if you right now we're using an in-memory system, right? So whatever things you search, whatever things you're uploading, if you just turn down the server and restart it, you will forget everything because it's saved in cache. So how we have a long-term memory solution to store all type of data, that including text information or all the video and image you're uploading to the system. How do we build the system?
Yeah, great question. Mm-hmm. So pretty much it's pretty simple from an ADK standpoint as far as moving from in-memory, session management to something that's persistent long-term. And the way you do that is by using what we call Vertex AI Memory Bank service for long-term memory. And you can use what's called Vertex AI Session service for all the persistent state. So sometimes you want to kind of store both the state as well as extracted memory artifacts from that particular conversation that you just had. And the way you do that is through leveraging Memory Bank. So Annie, do you want to kind of explain how Memory Bank works? And exactly how does it extract session information, generate memories as part of the ADK runtime?
Yeah, so basically so first you understand the concept of session. Session is our conversation or our raw data all stored in a session, right? So you want to generate this memory. Memory basically is the fact, it's a text information extract from this whole conversation. And then we want to extract this memory and then want to save to the Vertex AI Memory Bank. So next, every time we have the conversation, it will preload all the existing memory in the memory bank. For example, we have this conversation and we extract the memory. So our conversation can be very long and very detailed. And you want to extract particular memory like, this person had coffee this morning, or we have AI workshop this morning on Google Cloud live stream, stuff like that. And we store those text summary, the fact, and store that in the memory bank. So next time we ask questions, say, what do you do another day? This maybe March 31st morning, what do you do? And then you can say, they can do the preload or the memory and answer the question, say, you're watching this live stream together.
Yeah. So that's a really good definition and summary of how Memory Bank works. So overall, it extracts useful context from your session. It stores it and essentially in a persistent memory bank. And then you can actually then retrieve those memories later on for kind of enriching your conversations for future conversations or parallel conversations. And essentially, can you explain how it's doing the extraction? Is it programmatic or is it using a model behind the scenes?
Yeah, it's using the model, it's using Gemini model to extract the information. And also when we do the search behind the scene, it's actually semantic search. So you need to define an embedding model in the memory bank config when you do the search, but you do not have to implement anything. It's mostly encapsulate. So you just need to add some config and config how we're saving them by defining different topic and define the related model. Yeah, maybe, yeah.
Yeah, let's dive into it. Yeah, so essentially, as Annie just kind of alluded to, so when you're leveraging memory bank as well, you can kind of define what's called memory topics. So these are essentially categories or filing cabinets of information that you want to store as part of your session, your sessions that you're having. So maybe you want to store information such as search preferences. So say certain users tend to ask for certain skills or certain biomes. You want to perhaps kind of store that as part of the search preferences filing cabinet. Let's say you want to kind of store really critical information such as urgent needs context. You can store that as part of a different filing cabinet, or what we call a memory topic. So let's go ahead and create our memory topics that we're going to be using for memory bank. So to set up your memory topics, all you have to do is go to your deployed agent definition. So I'm going to go ahead and do that now. And come back over here to Cloud Shell and zoom in. And copy the wrong thing. Sorry, just make sure that I copy the right text. So now we're in our deployed agent file. And here's the different configurations. So we have memory bank definition, advanced configuration types that we're kind of pulling in from the ADK definition. And all we want to do here is make sure that we go to the memory topic down here and put these as our custom topics that we're using for our memory bank. So go over here to this placeholder and paste that in. So let's search for setup topic right here and just paste this here. So these are the custom topics that we're going to be storing long-term context for with our memory bank. Now moving on, what we're now going to do is go ahead and actually integrate this with our agent runtime. So now we have different filing cabinets that we want to store long-term information, but how do we actually get this to be filled when we're kind of interacting with our agents? We have to set what we call a callback so that at certain points in the agent cycle, it knows when to actually kind of load memories or retrieve memories. So Andy, you want to explain what a callback is?
Yeah, so callback basically for whole agent lifecycle, like before agents, so agent need to use a model, and the model is going to decide which tool to use and then answer the question, right? So every time before, so callback basically you want to intercept different point at this whole agent lifecycle so that you can add this custom logic at any point for the whole lifecycle. For example, before you're using the model, before agent callback, before a model callback, and after you're using the model, and before the model decided using the tool, and before after your agent is using the tool. So at every intercept for this whole life cycle, you can add your own custom logic here.
Yeah. Go ahead. Sorry.
What is the most common callback you use in your daily?
I would say my most common callback would be the before agent callback, only because it's a really good way of, let's say you want to inject your own custom logic, as you said. So oftentimes I use what's called model armor in many of my production apps, where often I want to filter information that gets passed to the model. And I use a callback for that. So the model armor gets triggered by the before agent callback. It checks for any malicious inputs. And then if it's not malicious, it passes it to the agent. Otherwise, it kind of shuts down the request. So I tend to use before agent. What about you?
Oh, yeah. So for me, I like to do after tool callback, so that I like to adding log or making sure I can track the memory state. So that's a really powerful thing. But yeah, for your example, when you say before agent callback, maybe you mentioned about model armor, maybe just quick brief intro for those of you, for those of the audience who don't know what is model armor.
A great question. So model armor is essentially a managed API provided by Google that you can use to filter for prompt injection, check for malicious inputs or sensitive data. So oftentimes in agentic applications, you want to make sure that if you're using it as a customer service agent or as part of perhaps a very health critical use case as part of a hospital workflow, whatever, you want to make sure that you're not perhaps passing in PHI to the model, or you're not getting sensitive information output from the model as well. So model armor is a good way of essentially just filtering for that information before it reaches the model or after it gets output by the model. So you can use it as before agent or after agent callback, either one.
Yeah. So in our memory example, what is the callback you're using here?
For our memory example, we're going to be using the after agent
Yeah, why
callback.
they're using after agent callback?
Yeah, it's just part of the agent runtime. So after the agent generates its output, you then want to then kind of process that output and then kind of extract useful memories from it. So it kind of just logically makes sense to put it as part of the after agent callback. But again, there's different ways you kind of customize it, and callbacks gives you the ability to kind of put it at different points in the agentic lifecycle. But again, for today, we're going to be using the after agent lifecycle. So here's actually where we're going to be doing it. So if you take a look at the lab, yeah. So here, if you take a look at the lab, we're going to be adding a callback called accession to memory. So whenever that agent gets particularly called, the root agent, essentially we're going to be storing memories to that memory bank. And that's pretty much the logic here. So let's go ahead and copy this here and scroll over to agent.py.
Yeah, so this accession to memory is basically, before in the diagram, you saw some like an arrow from sessions to what has a memory bank, right? So this one is basically you want to generate this text summary from the whole conversation and extract the memory and save it to memory bank. So this accession to memory is where we want to add generate this text summary and save to memory. Where we want to add generate this text summary and save to memory bank.
Yep. And the next thing we want to do,
and here is, the async is very powerful because it's not blocking the process.
Yeah. So I'm going to go ahead and add this here to the add memory bank tool, and actually make sure that I put this one in the right place. So you actually want to put this here.
Don't forget to share your screen.
Oh, thanks. Yeah, thanks. So actually, the use memory bank kind of logic switch is going to go here, and the accession to memory callback is going to go a little bit higher in the file. So just make sure that we put that in the right place. So that's going to go here. It's just how we want to define it. And that's pretty much it. So we've defined our function for adding session to memory via the callback context. We've also defined when we should want to use the memory bank via flag. And then we're going to load the preload memory tool.
This preload memory tool, basically, we can load all the existing memory from memory bank.
Yeah. And then lastly, we're going to add to the parameter for the root agent the ability to actually use this callback. So that's actually something you have to do as well. So we're going to add the after agent callback and add session to memory if we want to use the memory bank. Sometimes we want to just use the local memory or in-session memory. So we can kind of toggle between both by using this use memory bank flag in the file. And that's pretty much it. So
this is a flag in your .env file. You can turn it to be false and turn it to be on in the .env file.
Yep. And then lastly, what we want to do is, if you remember earlier on when we created the initial app, we used the in-session memory just so we can have something to start off with. But now that we've created the actual Vertex AI memory bank service definition, we can actually go ahead and replace that with the managed endpoints on Google Cloud for that. So all you have to do is provide the Vertex AI session service kind of class, the project you want to use, the location, and we're going to deploy this later on to Agent Engine if you want to continue. And then you can actually then use those deployed endpoints for your session service as well as the memory service. So go ahead and copy this here. And make sure that we go to the chat.py file. And we want to replace this right here with the right definitions. So with the new definitions. So here's our session service definition and our memory service definition. And that's pretty much it. So we're actually running out of time, but now that we've defined our Vertex AI session service and Vertex AI memory service, before you can actually start testing the app with this long-term memory, you have to deploy to Agent Engine. And Annie, do you want to explain what Agent Engine is quickly? Yeah.
Oh yeah. So Agent Engine basically, you can it's basically you can deploy your agent to Agent Engine, and with Agent Engine you offer like observability, and you can have the trace in there, and it's designed for your agent like runtime, and then you do not have to define your own runner if you deploy to Agent Engine. So basically, it's on Google Cloud that specifically designed for your agent deployment, and it has a session, has a memory, and everything there. So all the memory you generated in this scenario, you can see everything on Agent Engine or has AI memory bank. There's a specific tab there to show the memory over there. Yeah.
Yeah, and it's just one of the different ways you can deploy your agents on with ADK. You can deploy the agent engine for more of a managed experience, Cloud Run if you want more of a serverless experience, and then something like GKE or even on-premise if you want to be a little bit more managed and have a little bit more customizability. But yeah, that's essentially the end of our lesson. So anyone who's continuing, please feel free to deploy, and then you can kind of test the deployed endpoint and the deployed agent. But now we're going to switch over to the Q&A and kind of see some of the interesting questions that we've been seeing.
Yeah, put your question in the chat and let's look at them. Oh, I saw one question from YouTube from Aggressively Average, and they are asking if hybrid search is the best, why don't we just use it for everything? What do you think?
I would personally, for me, I would say hybrid search can add latency. So you have to understand that you're doing both keyword and the semantic at the same time. And sometimes if you have like a latency specific use case where you want to get the fastest results, you know that keyword might be the best, then keyword just makes sense to use it at that time. So you want to kind of be as efficient as possible in those scenarios. So hybrid does tend to give you the best results, but it adds, a degree of latency that you have to kind of be aware of. Yeah.
Yeah, also it really depends on use case. Sometimes maybe you only want to have the keyword search to search for the exact error code also. Come on, anyone has any question on the chat? We can take a look.
Yeah.
Do you see any?
So someone, yeah, I see on YouTube, Chetan Yadav asked, at what complexity threshold does graph RAG start outperforming vector only RAG in real world systems?
Sorry, I don't see this question.
Okay, I'll repeat it one more time. So Chetan on YouTube asked, at what complexity threshold does graph RAG start outperforming vector only RAG in real world systems? So essentially, when do you actually switch over to graph RAG versus just traditional vector search on RAG systems?
Yeah, I think it really depends on so basically traditionally RAG is you can basically have everything in the vector database and do the search. So graph RAG specifically you have in the graph relationship that you can traverse and have LLM context. So more often in the situation that you have the relational database. In this scenario, we have the survival and they have the skills and need. In real life use case, it can be, you have social media, who follows whom, right? So you have the relational database easily to traverse a graph node, or you can have, in the medical system, you have this patient and doctor, so they have relationship there. Yeah, what do you think, Ayo?
No, you explained it perfectly. Where I think there is definitely a threshold, and for graph, I would say there's also considerations when it comes to constraints. Sometimes people don't really have the full data visibility that you need to build a really performant graph database. So sometimes vector is kind of like the lowest lift to getting like a performant semantic search. If you have like all the columns and all the relationships that you need for graph RAG, it's obviously a good situation. But sometimes people don't really have all that data to kind of build that graph RAG database.
Yeah, I also saw a really great question from YouTube. Username is ATU start from, and they're asking, I am using Vortex AI memory bank for session and long-term memory. Is that correct approach? Should I use DB service as well?
I would say yes, absolutely. So you can use Vertex AI Session Service as a managed service, where you can connect it with different DBs like Cloud SQL or Firestore. So when it comes to saving session data, we recommend using like a DB service, and you can kind of manage it yourself with Cloud SQL as a backend, or you can use the Vertex AI Session Service, which is managed by Google. So there's different approaches, and then obviously use something like Memory Bank for persistent memory. Where you use Gemini to extract, as we talked about, and then you can have it inject in the different parts of the agentic lifecycle.
Yeah, definitely. So in the ADK, in today's example, you saw we have in-memory session service. We also have Vortex AI session service. So if you want to use DB service, you can use database session service and point it either locally to SQLite, or on cloud can be Cloud SQL and BigQuery and any decision you want. So essentially, but if you're using the database, you have to define your own table, and the way you're fetching them, you have to define what is the preference. It's adding a lot more flexibility, but also complexity. So it's really your choice of, it's a design trade-off that you want building manage service for you, or you want to add in your own custom logic and do your own design.
Yeah. Well, I mean, so many great questions, but we're out of time. But yeah, thank you all for tuning in. It was a great session. We hope you learned a lot. And until next time, I'm Ayo.
Annie, thank you so much.
And thank you.
Bye.
Thank you.